Good morning. Welcome to Chemical World. In last chapters, we discussed about what is matter and what it consists of, and we have understand that matter is made of atoms. And we have also discussed about different states of a substance like solids, liquids and gases. And we understand that how they can be distinguished. And we also learned that how the different mixtures or the solutions can be separated and what are different methods we have. Today we discuss about a chapter called atoms and molecules. Yes, we know that what is meant by atom. We also know that what is meant by molecule. In 19th century, many scientists have curious questions in their mind because they wanted to explore the nature. They wanted to understand how the nature is working. They have got different questions in their mind. Like, suppose you take an iron rod. Iron rod. It's a very good quality iron rod. And you kept in one place for a long time, long days. Then you have seen that the iron rod was rusted because of chemical reactions. Now it become rusted iron rod. Now the question comes in the mind that what happened to weight of the rusted iron rod, whether it increases or decreases comparing to previous iron rod. So weight of rusted iron rod increases or decreases. Another question. Suppose you have a charcoal and it has some weight. Now you burn the charcoal. Now what you get? You get ash. Now what happened to weight of the charcoal? After burning, what happened to weight of charcoal? And of course, weight of ash also. And another question. You have wet clothes and you kept in the open area for dry for some time. Then what happened to water inside the clothes? Water in wet clothes after dry. What happened? So these type of questions they got in their mind and they're eating their brain to get to have the answers of those questions. Especially, they are very much curious and serious to understand about what happened to the weight of the bodies in the combustion process. Like when you burn the magnesium in the air, what happened to the weight of the magnesium? When you burn the sulfur in the air, what happened to the weight of the sulfur? So in that way, they started thinking, and of course, they have given answers to us. Let me explain you those answers based on a small lab activity. In this lab activity, we're going to test that whether the mass or weight changes before reaction and after reaction cases. Let us see. So lab activity, in this, the lab items required are conical flask, right, test tube, lead nitrate, potassium, iodide, distilled water. Of course, we require a writing stand also. So, see here, you have taken a conical flask and take a fixed amount of water, say distilled water of 250 ml. So, pour the distilled water of 250 ml in the conical flask. Now add lead nitrate in that water. So now conical flask filled with water, distilled water plus lead nitrate. Lead nitrate a fixed amount, any amount you can take. Any amount means don't take very huge amount, like small amount. Okay, now in this conical flask, take a test tube. It's a test tube. Here also you fill the test tube with 250 ml of water. And mix the water with the potassium iodide, a fixed amount. Now keep the test tube inside the conical flask. So then the conical flask should be very big. Now this inside you have a test tube like this. It's tied to a thread. It is hanging through a thread from outside. So it is inside the conical flask. Right. Now you take the weight of the system, weight of this water lead nitrate solution plus conical flask plus test tube plus the solution of water to 250 ml of water potassium iodide solution. Take the weight. Let the weight is W1, which is weight of the system before chemical reaction. Yes. Now, second step, what I have to do, you just shake the conical flask so that the test tube will turn clockwise and anti-clockwise, and both the solutions are mixed together. When both the solutions are mixed together, there will be some chemical reaction. Then again take the weight. And the weight is W2, which is weight of the mixture after chemical reaction. So after taking the weights W1 and W2, what you have found? You have discovered that W1 is equals to W2. That is, weight of the system before chemical reaction is equal to weight of the mixture after chemical reaction. Or as in so scientific point of view, if you ask me to say, then I will say that weight of the reactants before chemical reaction is equal to weight of the products after chemical reaction. And this statement actually comes under a law called law of conservation of mass. So law of conservation of mass says that, once again I'm telling you, weight of the reactants before chemical reaction is equals to weight of the products after chemical reactions. So here I have used two words, reactant and product. So what is meant by reactant and what is meant by product? Reactant is nothing but these are the substances which are participating in chemical reaction. Product is the output, what you got after the chemical reaction. So in this lab activity, the reactants are this conical flask solution, water plus lead nitrate, and this 250 ml of water plus potassium iodide. These are the reactants. When you move the test tube for some time and it is turned clockwise, anti-clockwise, and both the solution is mixed, then the last solution what you got, the mixing of these two solutions, is the product. So, and you have discovered that these two weights are equal.